Are you excited? Because today, we're going to learn how to insert data into the database using EntityManager in JPA. This is where the magic happens. We've already defined our entity, now it's time to actually save some real data. So let's jump in and see how EntityManager helps us persist our objects to the database, step by step. Alright, in this video we're going to implement our SaveEmployee method using JPA's EntityManager. This method is called by addEmployee in our employee service, so it's the backbone of inserting new employees. Now, if look at the employee repository interface on my screen, you'll see we've already built similar logic using JDBC template, named parameter JDBC template, and JDBC client. But today we're leveling up, we'll re-implement all of these operations using the EntityManager, and we'll even add some extra JPA magic. Okay, let's get started. Create a new class called Employee Entity Manager Repository. Annotate the class with a repository, so Spring picks it up as a repository bean. Implement the Employee Repository interface. Alright, in this video we're going to focus only on the SaveEmployee method. We'll leave all the other methods in the repository as is for now. Okay, now it's time to grab our EntityManager instance. This is what lets us talk JPA. Okay, first up let's declare our EntityManager field. Okay, so we need our EntityManager instance. How do we inject it? Sure, you could use it auto-wired like any other Spring Bean, but that's not recommended for EntityManager because of thread safety concerns. Instead, we use the official JPA way, the @persistence context annotation. One thing to note, you can't put @persistence context on a constructor parameter. You have two options. First, field injection, and second, setter injection. I like setter injection. Okay, I'm using setter injection here to wire in the EntityManager. But if you prefer, you can also annotate the field directly with @persistence context, as you saw a few minutes ago. Both approaches work, so pick the style that suits you best. Okay, let's implement our SaveEmployee method now. So, we are going to use EntityManager. And it gives us this awesome method called persist. It's like magic. You just pass the entity, in our case the employee object, to it, and EntityManager does all the hard work for us. Okay, so now we call the persist method and pass our employee object into it. Okay, so here's the magic. With just this EntityManager.persist employee line, our employee object gets inserted into the database. No need to write multiple lines of code, no additional logic required. JPA takes care of it all for us. Okay, remember when we were using JDBC template and named JDBC template earlier? We used key generator to fetch the employee ID and then save it. But you might be wondering, how does it work in this case? Well, the magic happens with the EntityManager's persist method. When we call persist method, EntityManager handles all of this for us. We don't have to do anything extra. Remember, when we defined the employee entity, we marked employee ID with the @ID annotation. This means that EntityManager will automatically set the employee ID for us. Whatever ID is generated by the database, it will fetch and assign it to the employee ID field in our employee object, all on its own. We don't need to worry about manually fetching or setting the ID. JPA takes care of that seamlessly. Cool, right? So, as you can see, the employee ID in the employee object is already updated by the EntityManager. We don't need to do anything extra. The ID is automatically generated and assigned by the database. All we need to do is return the employee object from our SaveEmployee method. Simple, right? Okay, see my screen, it's done. Our SaveEmployee method is complete with just one line of code. This is how simple it can be with EntityManager. It handles everything for us. Just pass the entity, and it takes care of generating the ID and inserting the data into the database. No extra hassle. Okay, now let's move on to the employee service class. Earlier, we were calling the JDBC client repository for repository. Now, we need to replace that with our employee EntityManager repository bean. Okay, add some log in SaveEmployee method. Alright, now let's start the application. Okay, we got an issue here. But no worries. Okay, I debugged it offline and found one problem. Our project build and install is failing. See, the error is saying unable to find main class, and our employee DAO build failed. The actual issue is with the Spring Boot Maven plugin. I mistakenly put it in the parent pom.xml, but it needs to be present in the pom.xml of the module where we want the executable jar. So, what we're going to do is move the whole build property of the Spring Boot Maven plugin from the parent pom.xml to the employee API pom.xml. This will ensure that the executable jar is properly built for the employee API module because this module is the one containing the main class, which is annotated with that Spring Boot application. The Spring Boot Maven plugin needs to be in the module that has the main class to build the executable jar. So, by moving the plugin configuration to the employee API module's pom.xml, we'll be able to build and run the application properly. Let's make sure everything's in the right place now and rebuild the project. Okay, let's install it again. And there you go. The installation is successful this time. Okay, now let's start the application again. Okay, great. See, the application got started successfully. Now, on my screen you can see something highlighted. It's the database info log. Let me quickly walk you through what you're seeing. Alright, now don't worry if you're seeing a few undefined or unknown entries in these logs. This is totally normal. These are just info level logs, most likely coming from Hibernate's internal class. Data Source Connection Provider RI-MPL. And yes, I've already debugged this offline. Our Hikari data source is configured perfectly, exactly the way we set it up earlier. So no issues at all, you're good to go. Also, quick note. If you're using a lower or higher version of JPA, you might not even see these logs in your console. But don't worry. It doesn't affect your application's functionality at all. As long as your data source is properly configured, everything is running just fine. On my screen, you can see a Spring JPA property called spring.jpa.openInView. By default, it's set to true. What this does is keep the persistence context open for the duration of the web request, even during view rendering, so you can safely lazy load associations in your controllers or views without running into lazy initialization exception. We're not going to change this setting right now. The default works fine for most applications. We'll dive deeper into the pros and cons of OpenInView in a separate video, so stay tuned for that. Alright, let's open dbeaver and check out our employee table. See this? We've got 44 records in total right now, and the last inserted employee ID is 52. Alright, before we fix anything, let's see what happens when we call EntityManager.persist without a transaction. Remember, in our last video, I emphasized that persist must run inside a transactional context. Now, if you look at our saveEmployee method, we haven't added any transaction. So before fixing it, let's first see what happens if we forget to add a transaction. I'm going to send a post request to add a new employee. Name, Rohit Kumar. Age, 45. Department, Developer. Let's hit the request. Okay, look at this error we just hit. No entity manager with actual transaction available for current thread cannot reliably process persist call. This is JPA telling us, hey, you called persist without any active transaction, so I can't commit your insert. Okay, notice here that we didn't see our error logged in the console. That's because we never caught and logged the transaction required exception in our saveEmployee method, so it just bubbled up and stayed silent. Plus, our global exception handler doesn't have a rule for handling transaction required exception, so Spring never turned it into an HTTP error response or printed a stack trace for us. So how do we fix the transactional issue we encountered when hitting the Add Employee API? We need to run EntityManager.persist inside a transaction. Okay. Add the @transactional annotation just above our saveEmployee method. This magic annotation tells Spring to automatically open, commit, and close the transaction for us. We'll cover all the details of a transactional in a separate dedicated video, so for now, just add it in and let's move forward. Alright, we've wrapped our persist call in a transactional. That means Spring will now open a transaction before the method runs and commit it afterward. Let's restart the application. Switch to Postman and hit our saveEmployee API again. Okay, we just hit another exception, unable to locate persister for com.entity.employee. What's going on here? Well, since this is a multi-module project, Spring Boot isn't automatically scanning our entity and repository packages in the employee DAO module. So when Hibernate starts up, it can't find our employee entity to map it. Let's fix this. Open up our main application class, Employee Service Application. Okay, to get Spring Boot to pick up our JPA repositories, Spring provides the @enable JPA repositories annotation. This tells Spring Data JPA exactly where to find your repository interfaces. Okay, follow along on my screen. Add the @enable JPA repositories annotation to our main class. Okay, and in the base packages attribute, we pass the package where all our repository interfaces are located. So in our case, that package is com.gan.derpun.dao. This tells Spring, hey, scan this package for any JPA repositories I've defined. Spring will handle everything from proxy creation to implementation behind the scenes. Alright. So far, We've told Spring where to find our repositories using the @enable_jpa repositories annotation. But now the question is, what about our entity classes? Like the employee class, which we marked with @entity, we also need to let Spring know where to look for those entity classes. And for that, Spring provides an annotation called @EntityScan. So let's add that now, just like this. Here, you pass the package where your entity classes live. In our case, entity is in the com.gan.derpun.dao package. Okay, now Spring knows exactly where to scan for our repository interfaces and entity classes, thanks to the @enable_jpa repositories and @EntityScan annotations. So what's next? Start the application again. And now, let's go back to Postman and hit that API once more. Awesome. See, this time we got a success response in Postman. And the coolest part? We got employee ID equals 53. Even though we didn't manually set anything at all. Like I said earlier, EntityManager.persist takes care of everything behind the scenes. Generating the ID, setting it back into the object, all of that happens automatically. Okay, now let's quickly open dbeaver. And look, employee ID 53, Rohit Kumar, age 45, profession developer. Successfully inserted into the database. Alright, so it's working perfectly. But now, you might be wondering, what exactly is EntityManager doing? Is it using something different, or totally new? Like some magic? Well, the answer is, not really. EntityManager isn't doing anything dramatically different. Internally, it's still using the same SQL queries, similar to what we do with JDBC template or even plain prepared statement. But the difference is, EntityManager works as a layer on top of all that. It adds abstraction so you don't have to manually write queries, bind values, map results. Instead of thinking in terms of tables and columns, you work with Java classes and objects. That's why we call it ORM, Object Relational Mapping. So behind the scenes, yes, the SQL is still running. But from our side, we just say, hey EntityManager, here's my Java object, you handle the rest. And that's the beauty of JPA. Okay. To actually see what SQL queries EntityManager is firing behind the scenes, let's enable Hibernate SQL logging in our project. For that, open your log4j2.yml file. Now just follow along with me. Let's add a logger entry for Hibernate SQL. org.hibernate.sql logs the actual SQL queries. Change level to debug. Perfect. We've now enabled debug logging for org.hibernate.sql. Let's start the application again. Hitting the same API to save employee data one more time. Done. Now, let's jump back to the console logs. See this? Hibernate printed the SQL query. Look closely, you'll see some question mark placeholders in the query. These question mark are placeholders used in prepared statements. Hibernate, just like JDBC template or JDBC client, uses these placeholders to ensure the query values are bound securely at runtime. So, to be clear, EntityManager is running the same SQL queries that we would manually execute with JDBC template or prepared statement. But Hibernate adds some extra layers, managing things like transaction handling and entity mappings for us, which saves us from writing a lot of boilerplate code. One important note, don't enable these SQL logs in production unless absolutely necessary. Why? Well, it might seem helpful to see all the SQL queries being executed, but it actually increases your log file size a lot and can lead to performance issues. It's more of a development or debugging tool. In production, you'll want to keep your logs clean and focused on errors or critical information, not every SQL query being run. So, use it wisely, only turn it on when needed for troubleshooting. Okay, so to summarize what we covered today, we implemented the Save Employee method using EntityManager in our Spring Boot app. We saw how transactions are required for persist operations and added the @transactional annotation. We also explored how Hibernate executes SQL queries under the hood and why EntityManager uses the same queries we'd run with JDBC template but in a more structured way. In our next video, we'll dive into why a persistence context is recommended over at AutoWired for injecting the EntityManager. Don't forget to hit the subscribe button, turn on notifications, and give this video a thumbs up if it helped you. See you next time.